This is the example video for factoring by grouping. So let's take a look at the first example. We'll group our first two terms together and our last two terms together. So taking a look at our first group, I know that 5 goes into both 35 and 30, so I'll take out a 5. And both terms have an x as well. So that is my GCF for that group. When I divide 35xy and negative 30x by 5x, I'm left with 7y minus 6. For my second group, I'll do the same exact thing, look for GCFs. So it looks like here, I can take out a positive 2. I can also take out a b. And when I divide 14by and negative 12b by 2b, I'm left with 7y minus 6. I know I'm on the right track because my expression in the parentheses are identical. So that'll be one factor. And my other factor will be whatever is outside of the parentheses, so 5x plus 2b. I've been asked before if it matters which order a factor's in. Generally, or more often than not, if there were a greatest common factor here, that greatest common factor would be out front. But besides that, it really doesn't matter what order your factors are in. Actually, it doesn't matter at all. Think of it like this. If you had 2 times 3 and 3 times 2, is there any difference there? No, they both equal 6. Okay, so their product will be the same regardless of their order. All right, next example. I've grouped them, the first two terms and the last two terms. Now I'll look for GCFs. So I know 8p squared goes into both of them. And that leaves me with 5p minus 7 when I divide both these terms by my greatest common factor. And for my second grouping, I know I can take out a negative 3. And that leaves me with 5p minus 7. Okay, on the right track because these expressions are identical. So that'll be one factor. And my other factor will be whatever's outside of parentheses. So 8p squared minus 3. One situation that will arise, if you ever get to a point where you've taken out your GCFs and your expressions are very similar but not identical. For example, you had 5p minus 7 in this parenthesis set right here, and you had negative 5p plus 7 in this set over here. Well, that's not good enough. We need them to be identical. So if the only difference are their signs, just take a negative 1 out. So I knew here, instead of taking out a positive 3, I could take out a negative 3 because I needed this sign to be a subtraction sign, and I needed the negative 15p to be positive 5p. Okay, pause the video if you need more time. All right, next example. So I'll group 56az plus 28ah. I know both of those are divisible by 28a, and that will leave me with 2z plus h, and I know that negative 16yz and negative 8yh are both divisible by negative 8y. So when I divide negative 16yz and negative 8yh by negative 8y, I'm left with 2z plus h. These factors are the same, so that'll be one of them. My other factor will be 28a minus 8y. So for me, I'm going to take a look at these factors. 2z plus h is completely simplified, no greatest common factor there. But 28a minus 8y, there's another greatest common factor we could take out. In fact, both of these terms are divisible by 4. So what I'm going to do, I'm going to take a 4 out of this. So if I take out a 4, I'll be left with 7a minus 2y and 2z plus h just carries down. And that is completely simplified. All right, let's take a look at the next example. So before you write anything, let me walk through this example really quick. So if I group the first two terms together and group the second two terms together, right here I can pull out a 2m, and that leaves me with 6n minus a. So for my second term, I have no greatest common factor here. So the order in which these terms are for this polynomial, we cannot factor by grouping. So we need to switch the order around so we can in fact group them together. So let's try a different order. How about we try 12mn plus 8m squared minus 3an minus 2am. Okay, just trying out something different. So at this point what I can do, I can group the first two, and I can group the last two. I know here I can pull 4m out of both of them, and that will leave me with 3n plus 2m. And looking over here, I can pull out an a, and I can also pull out a negative sign, and that should do it. So if I pull out negative a, and I divide both these terms by negative a, I'll be left with 3n plus 2m. So now I'm all set because my expressions in the parentheses match each other. So my two factors are going to be 3n plus 2m and 4m minus a. So if you ever get in a scenario where it's not in order the first time and you know you can't group them or you can't factor them by grouping, try switching the order around and you should be all set.